So Quentin, how did you get interested in computer science? Like what sparked your passion? Because I know you've been into music forever. So when did it start with the whole computer science thing for you?
So computer science was something that my dad had suggested to me because I've always been good with computers. Before I was computer science, I was pre-med. And I wanted, I was like, I want to go be a physician assistant. I want to be a doctor. I want to work in the medical field. I was really into biology. Ever since I was a kid, I was into biology. I'm also deathly afraid of needles. Working in the medical field, you kind of have to you got to get your regular blood work done. You got to be vaccinated because you're working with sick people.
Is it that you don't like them on yourself or just like being near
I
them or?
I'm fine being near them. I can give someone else a shot, but I don't like shots.
Right. I'm the same way. I've always gotten like a little lightheaded or like if you get your blood drawn and stuff, I kind of shy away from that.
Yeah, I was 10 and I fist fought the nurse when they had to draw blood for me.
Wow.
Fought the nurse and my dad. My dad's like 6'2", 250 pounds. And, you know, I was pretty, my parents were pretty strict, it would take a lot for me to actually want to throw hands at my dad. I was terrified. I did not want that shot. So I changed my major to computer science right around then. It was about 2 years into my degree. So I just did my GE anyway. So it was, okay, whatever. I got to do more math now.
Right.
CS, or just computers in general, I think, has just been something that I've been interested in since I was a kid. I mean, even before music. I've been playing music since I was 5, but I started on the computer when I was like 3. We first got our computer. And I think by about 10, 11, I was resident tech support. I was like, hey, we want this movie. Can you get it? And I was like, yes, I can definitely download that movie for you in what is most definitely a very legal way with my allowance.
Well, that's cool. So when you were getting into computer science and you changed your major, had you already learned any programming languages, or were you just getting started with that?
So I knew a little bit. Growing up, I was really into video games, and I had RPG Maker, which I think was RPG Maker VX and VX Ace is what I was using at the time, and those both programmed in Ruby.
Okay.
So I had to learn RGSS2 and RGSS3. And then after that, there was other stuff like Mugen I used. I don't know if you're not familiar with it. It's like a fighting game where you can make characters. It's like
okay.
Open sourced fighting game kind of.
Right.
And so I would try to make characters in Mugen. I would do stuff where I hacked my Wii and I had to do stuff like that. It's not so much programming languages, but it was basic stuff, basic technological competency stuff where I could look at it and say, okay, I understand this.
Right.
I get the logic behind it. And so I think that gave me a really good platform to start off of when I started programming.
Right. I've actually heard that from a lot of different people who've done computer programming, is that video games are kind of one of the first jumping off points that get people really into it. And so that's cool. And so you mentioned Ruby. Do you still program in Ruby anymore, or have you not quite as much?
No, not really. And even when I was using RPG Maker, I was never particularly good at Ruby. I remember there were people who were writing these massive 2,000 line code whole systems. They wrote entire game engines in Ruby, and I'm little 13-year-old me looking like, this is crazy. But I'd go through and I would want to, maybe I want, instead of the window to show up in this corner over here, I want it to show up in this corner over here, and I would go through the code, kind of Control F, window position, and eventually I'd find the variable that controls it, tinker around with it a little bit, screw around and find out pretty much. Right. Security wise though, it's not a lot of programming as much anymore as it is just making policy.
Right.
Policy, you have to pretty much, you're the guy nobody likes to see, because when you show up, you make their lives difficult. When you have to reset your school password every 3 months, and they won't let you use any of your last 10 passwords. And you're like, I don't care if someone hacks into this account. That's your problem. But it's that's pretty much what the security aspect is all right, well, let's enforce this policy. Let's make sure the passwords are set up right. Let's make sure that the group policy is right. Setting up the firewall that makes it really difficult for anybody to actually get out to the internet, but also makes it difficult for people to get in and hack our stuff. With security, you can go to basically any company in the world, because everybody is digital now. And if
Right.
it's digital, that means it can be hacked. And so everybody at some point needs some level of cybersecurity.
So going off from that, so what are some of the main things that people can do to stay secure?
Number one, don't download things off of sketchy websites. It sounds like it's redundant, but you know, a lot of people like they'll download something and they'll ask me for help, and I'm like, well, where did you get this? No, you know, this is totally not a sketchy website.com, and I'm like, well, well, you see, you know, making backups of everything is really important. Having redundancy, especially anything that if you would be devastated if it was gone, back it up. If you would be mildly inconvenienced if it was gone, probably still back it up. You know, password complexity is really big. You know, when they talk about like you need to have a uppercase character, a lowercase character, that's all really good. But also the other thing too is you want to have a longer password. The longer the password, the more it's exponentially more possible combinations, and that makes it exponentially harder for someone to brute force your password, where they try every individual, you know, they go A, B, C, all the way down, and they go AA, AB, and BA, BB, and et cetera, going through every single possible combination. Well, when you make it a really long password, that means that you have more possible combinations, and the brute force has to try more things. You also don't want to use commonly used words or like, you know, password 123. Everybody's going to hack that because the hash for it's already known. You know, so they'll be able to just try. And in fact, without even trying to like hack it and really figure it out, a lot of times hackers will just type in password 123, hello,
Right.
1 2 3 4 5 6. You know, those are all very common and like basic things that people do because they're lazy and they don't want to set up a password, or they want to set up something that they're not going to forget, but it makes it really easy for other people to remember it, or to guess it, I should say.
Right. Yeah. And I even heard something about that. If you think you're being smart and substituting like a dollar sign for an S or like a zero for an O, they figure that out too, and they'll have algorithms to substitute those commonly used letters in. So you're saying the best kind of password is one that's long because it takes a long time to, you know, brute force it exponentially.
Yeah. So like a good one, like off the top of my head, would be like 808 disturbing the peace exclamation point. Boom. It's long. It's got numbers. It's got letters. If you know, disturbing the peace, capitalize those. That's a lot of complexity, and it's a long password. You know, and once again, every character is going to raise the total possible amount exponentially. So it makes that a very strong and difficult to crack password, as long as nobody knows you used to play in that band. You know, maybe not for you or me. It'd be like, well, he was in this band. We can try it. You know, but anybody listening out there probably also don't use it because people will probably go figure out the hash for it and put it on a rainbow table.
Right. And you're mentioning hashes. So could you explain to the listeners just a little bit about that?
So when you enter your password on a website, when you set up that password, they never actually store your password. That never gets sent. What they do is they take that password that you entered in, let's say it's password 123, they run that through the hashing algorithm and they store the hash, because that can't be reversed, or it shouldn't be reversed at least.
Right.
Now, when you enter your password to log in, all they do is they just hash the password you logged in with. They compare it to the password that's stored. And if those two passwords or those two hashes are the same, then they say, okay, this has to be the same password. And so that's one way that companies and cybersecurity experts work to prevent people from getting your plain text password and being able to use it, is they just store it in a way that's not usable. You can't enter that hash in the password thing, because if they're going to hash that, and now you get a hash of the hash, which is not what you want.
And yeah, and you know, you'd see how you know, if you're having just the plain password stored on a website in some kind of like, or in like a database or whatever, and then that leaked, and then that would give hackers a whole new table of passwords to try.
That happened like if you remember Neopets. Neopets is infamous. They used to store passwords. I don't know if they still did, but I know that they used to store passwords in plain text. And how people figure that out is that if you went through the password recovery system, I forgot my password, enter your email, and they will email it to you, and they emailed you your password. Any company that can email you what your password is, don't trust them. They're not doing the cybersecurity right.
Right.
It should never know what your password is because it should never be stored. It should only be stored as a hash.
Would you ever recommend someone downloading like, I don't know, McAfee or like some kind of security software for their computer? Or
Absolutely. Absolutely. Okay. I don't particularly use McAfee. I use AVG and Malwarebytes. You also want to make sure that people understand the difference between antivirus and anti-malware, where antivirus is looking for a program, it's looking for specific things. It already knows like, well, this here, like this is in our database, and it just checks like, is this a virus? Yes, this is a virus. Okay, get rid of it. Whereas with anti-malware, as opposed to looking for specific things, it looks for behaviors. It's saying, this is sus. I don't know, vote it off. I think this is, I don't like it. And so in my opinion, I think it's really important to use both antivirus and anti-malware, where antivirus is really good at detecting things that are already known. Anti-malware is good at detecting things that are new and emerging.
See, I've had some situations with like antivirus and anti-malware where you download it and, the software itself could be a virus or some malware, like it'll embed itself in your system and it'll be hard to get rid of it, like, promising to clean up your computer, but really it's just
making it worse. Virus.
Yeah.
Yeah. And, I look at that and it's really just being really careful about who you go through and where you get. I know Malwarebytes is really reputable. There's virustotal.com where you can actually upload a file and see if it has a virus in it. So the other thing that people can do that I don't think a lot of people understand how it works is you can run things that may or may not be sus. If you're like, I don't know about this, then you can run that in a VM. And you can see the behavior that it has in the virtual machine, which when you do that, it's like, well, this didn't get into my real computer, so I don't care. I can just delete the VM. That does only go so far. Eventually, you could have a virus that comes out that knows how to, it knows it's in a VM and that it either doesn't work while it's in a VM, or it knows how to like cross out of the VM and into the real system. I haven't seen that, but nothing's impossible,
Right. You're giving people ideas.
I demand at least 5% of all the profits and community.
So what about VPNs and proxies and, protecting their IP address and their identity when they're online?
Yeah, I think VPNs are extremely useful. I use one, and like I'm not sponsored or anything. This is just what I use personally. It's called Windscribe. It's 10 gigabytes a month for free, and it's a VPN service that I can like go on and like, I need to legally purchase these things. I just don't want, I don't want the government to know that I'm legally purchasing this like King Kong Skull Island movie, And as the VPN's coming through, it encrypts it end to end for people who don't know what they do. It encrypts it on the data on your end, sends the request out to a VPN server. The VPN server then, as I understand it, they should be decrypting it there and then sending it out where it needs to go, but it never passes you. So you are not, nobody knows it's coming from you. Nobody knows that it's coming from you. All they know is that you're sending data to a VPN server, but it's encrypted. So they have no idea what's being sent and they have no idea what's coming in. It's like, think about it like a protected tunnel for between you and the VPN server, and then they send the data off and take data in for you.
And so, and then when you're browsing, are there any search engines you'd recommend? Like I know Google, tracks people a lot and stores cookies. And would you recommend something like Duckduck Go or some other?
Yeah, I know a lot of my techie friends use Duckduck Go. I'm not super worried about Google tracking me. I'm like, look, if you guys want to know what I'm looking up, then cool. Like, yes, I want to know how to optimize a barbarian in Dungeons and Dragons. I am a nerd. But if people are really concerned about that, if they have concerns about their privacy, then yeah, I would recommend something like DuckDuckGo, which their whole platform is like, yeah, we don't track you, know.
Or if you wanted to go up a whole level, you could do something like Tor and have all kinds of layers of protection.
Many layers of protection are needed for Tor.
Right. Although, unless you're doing something sketchy, I don't know if it's really super necessary.
Yeah, most of the people I know who go get a Tor browser and they're using Tor, it's like they're probably doing something sketchy. And I'm just like, shame, shame.
Is there anything else about encryption that would be important for people to know, or anything based on your background that?
So encryption and hashing are kind of similar, but they're not the same. With a hash, you're not storing data to later be decrypted. I think that's a really important thing for people to know, is that with encryption, the point is that you can encrypt it, but there is a key that you can use to decrypt it, so you can get the data back. With a hash, you don't really want that to happen. So it's made specifically so you can't reverse engineer it. With encryption, there's a bunch of different types. As I understand it, the one that they use most of the time nowadays is RSA encryption, which, without going too in depth, you take two prime numbers, let's say 7 and 11, you get another number, which is 77. There's only two ways to get 77 from those two numbers. And that's going to be with 7 and 11 or 77 and 1. We're going to ignore 77 and 1. And so now you have your two keys, you have 7 and 11. So you might have that the encrypted data is 77. And you need to now find, okay, well, what two prime numbers multiply to get 77? We know probably off the top of our heads, okay, well, that's 7 and 11. It's easy to think about. But now we can start getting to like really massive, like 9-digit long prime numbers that multiply into some like obscene monster of a number that I don't even want to think about. And then that is what we actually get for the encryption key. And so like that's where our computers, they will take forever to figure out what two prime numbers multiply into that. Because first they have to go through every number on the left, and they also have to check every number on the right if they're brute forcing it. So, you know, you're kind of guessing. Some of the things when they talk about are like, it would take 10,000 years or something for the computer to be able to crack that, which makes it computationally secure, where it can be cracked and it can be broken,
right.
But it's just going to take so long that the data, like by that time, like who cares what, you know, Devon's Neopets password was? Devon's not here anymore, guys.
It's 808 disturbing the peace with an exclamation point. Just in case anyone's
guess that. So like back to like the encryption decryption thing. So like with RSA, I think the really interesting thing that's going to happen going forward is Google just last year came out and said, hey, we've got quantum computing. We've made a quantum processor. Once again, without going too far into that, quantum processors are just going to blow security out of the water as it is right now. We're really going to have to rethink it, because I remember like what would take a normal computer 10,000 years, Google was able to crack with that thing in like 11 minutes or something. Just ridiculous like that. And I was sitting there in my network security class as this got announced, and I'm just like, am I wasting my time? Is my major going to be obsolete?
So then, do you have any ideas about like what the future of security would look like?
We're going to have to write algorithms pretty much and like invent things that work in the quantum space, I think, you know, especially for security standpoints. There was a point in time where I don't think that they really had in-depth computer security, especially when you think about, well, computers back in the day really were just big calculators.
Right.
You know, they weren't doing everything that we have them doing today. So it's just as time goes on and we rely more on computers, we're going to find new ways to break them, and then people are going to have to find new ways to stop people from breaking them.
What do you think about like, you know, blockchain and Bitcoin, where it's more about consensus, like everything's out in the open on some kind of ledger, but then it's about the consensus of the majority of other people who are doing the computational work? Do you think stuff like that's going to take off in the future, or do you think that's trendy, or what are your thoughts on that?
I'm not super familiar with Bitcoin at the moment. I haven't gotten into crypto like at all. I have some surface level knowledge on blockchain. I think blockchain is actually really neat and really interesting, especially for things that need to have integrity. So if somebody goes in and changes it, everybody will know, wait, hang on, you're not supposed to do that. You know, I think that could be interesting in, say, like a corporate environment. You know, if you have everybody in the office is on the same blockchain, it's like, okay, well, if you change anything in here, we're going to know exactly who did it, and we're going to come find you about it. What's up with that, you know? But I don't think that that's going to supersede any sort of security. I think at the end of the day, you're still going to need security preventing outside eyes and eyes that aren't supposed to be on this from getting into it.
Do you think we'll ever get into some kind of future where like privacy doesn't exist anymore, or like if you want to be private, you have to like write it down in a book or something like that? Or
I think it's possible based on just how technology goes. I think it's totally possible that, eventually we'll have the hunter seeker, you are being watched all the time, the electric eye up in the sky. But even with technology, I think that there are ways that we can get around that. Just off the top of my head, it's like, well, if I want to make sure that nobody is hacking into my computer, the easiest thing to do is to just pull the network card out. It's like, yeah, good luck connecting to it if it doesn't have a way to connect.
So how is the day in the life doing security in real life different from like the kind of hacking you'd see in the movies?
So like I said earlier, with security, a lot of what you're going to end up doing is policy. You're not even so much like, you're not sitting there like, oh man, this hacker's coming in and like, let me fight him off. It's a lot more like, all right, I'm going to come in here and I'm going to install this firewall and I'm going to tell everybody to change their password every like 2 weeks and then we probably won't have a problem. And if we do have a problem, then I have to go back because attacks, generally, you're not going to know that they happened until it's already done. Once the attacks happen, it's like, oh, snap. Okay, well, okay, let's make sure that doesn't happen again. So it's going in and like being able to look at logs, being able to understand how they got in and like, okay, well, like, let's see if I can replicate that. And then once you know how to replicate it, now you can play the part of the hacker. This is called red teaming, where you play the part of the bad guy and then you try to set up your security so that you can't break into it in the same way.
It's still very interesting, but it's not going to be quite, what you'd see in some kind of like spy movie or something where you're going back and forth, like typing like super fast, like,
super code back and forth, typing C at, 200 words per minute.
With like a zoom in on the face and the keyboard and stuff.
Yeah, the green, it's always green text. I don't know if you noticed, it's always green text, a black background, reflecting off of their glasses.
I also wanted to mention, your other big passion is music, and you're the drummer for Phantom Witch, which is your, it's your baby, and you've been, I remember back in the day when it was Phantom.
We sucked. Back when we sucked. Yeah.
But since then, you guys have like, actually gotten a lot of success, and you put out Death as We Know It last year, right? And you got to tour on that. And then I saw, don't you guys have a new song that came out pretty recently?
Yeah, we had a song that came out. We released it a week before Election Day, so that should tell you a lot about the content of the music. But the song's called The Guillotine. We are working on new material. That is 100% out there. Everybody should know we are hard at work on some new material, and we can't wait to release it and show everybody at home.
Oh, that's awesome. And then you're also the bassist for a band called Section 5150. How's that been going?
That's been going good. We're taking a break. Not like the band's not doing anything, or we're going to break up. But with the holiday season, people are moving. If I'm starting this new job, we're taking a slight break just to like get our lives in order. But we are also working on new material with that band, so we're really excited to get that out as well.
That's cool. And I know with COVID and everything, it's made it hard to tour or to play any shows or anything like that. But I did see that you've been doing through Rock Immortal, and it's on rockimmortal.com, and I'll have links and stuff. There's a Rock Talk podcast, and it's kind of like a live web series too, right? Where you guys talk with different band members and different all kinds of cool stuff. So how'd that get started, and like what was your?
So Rock Immortal is a company that I started with my good friend Russell. He came to me and he was like, hey, I want to do live shows. I want to be able to, put on shows in the Bay Area. And he came to me with the idea, and I was like, this is a great idea. Let's do it. We put on a show last year in December, and then COVID hit, and it was like, oh, okay, well. So we started reaching out to people in the music industry that we know. I know the guys from Warbringer really well. So I reached out to John Keevil. I reached out to some of the guys from Hatchet. We reached out to some of the guys from Carcass and Exodus and whatnot, and like, hey, we'd like to do an interview with you. got a lot of traction with that actually, and like we got picked up by Blabbermouth at one point, and I was like, whoa, that's crazy, because we were getting these people that we know pretty personally a lot of the time on the show, and we were able to talk to them and really get inside scoops on things that people didn't know anywhere else. We got to do one of Will Carroll's first interviews after he recovered from COVID-19.
Wow. Well, that's pretty impressive. And, I'd encourage everyone to go check that out if you're into metal music, especially thrash metal. But something that you and I have in common is that we're both into music and computer science and coding. So are there any overlaps that, you see between those two fields, or something that draws you to both of them?
So I think that a lot of metalheads are also nerds. I think a lot of computer scientists are also nerds. And like we were talking earlier, we talked about how getting into computer science, a lot of people got into computer science through video games, and a lot of people also get into like rock and heavy metal through video games. I was one of those. I know I talked to Conan from Ex Mortis and Carlos Cruz from Warbringer, and they were both like, "Oh yeah, dude, Sonic the Hedgehog got me into music," and like 100%, that's what it was for me too. Like I played Sonic Adventure 2, heard Live and Learn, and I was like, yeah, cool. I like this. I'm with it.
Right.
And so a lot of those old video games, you can look at Mega Man, where the soundtracks for Mega Man were, Dr. Wily Stage 2, awesome track, well composed, and it kind of sounds like a metal song, and you can compose it, like recompose it as a metal song, and it really comes off that way. Guitar Hero, another video game that, for obvious reasons, has a lot of ties with rock and heavy metal culture. And I think even more famous than Guitar Hero for this, Doom, who literally just took metal songs for the soundtrack and then like tweaked them just within the like realm of legal, like legally copying it. There's like a whole video on YouTube you can look at it. It's just like, yeah, here's the song from Doom, and then here's the metal song that they like copied it from, and it's very apparent that it was copied. But all of that stuff really, I think, helps to draw people who are already into video games and already into like this techie stuff into the musical field, while at the same time they're kind of naturally, because of their interest in technology, I think they end up coming over into the computer science field.
Are there any other things you wanted to touch on about security or networking, or how to turn off and on a router, or
unplug it and plug it back in and you're good? Yeah, I think a lot of things, like a lot of what I learned by myself. I'm kind of a self-starter in a lot of ways. Music, I was the same way. I taught myself how to play drums. I taught myself how to play bass and guitar. And I taught myself a lot of my baseline knowledge of computer science. Of course, I went to college. I got my degree in it. Now I can tell companies I have a paper that says I know things, so pay me money. But, it's not always going through the degree. One of the people at the company I'm really hoping I get to work at here, he is a security specialist, and he's already talked to me. He's like, yeah, man, like I taught myself how to do security. I didn't go to college and get a degree in it. I learned it. I studied it on my own time because I was interested in it. And that guy knows his stuff. I mean, he knows his stuff really, really, really well. And, I am just like really awestruck at his knowledge on this. And I'm like, I got to pick this guy's brain. I got to pick up everything he knows. So a lot of that stuff, people, if you want to learn it, just go look up some YouTube videos, go pick up a book on, on coding, on programming, on security, and just work through it. That's honestly what a lot of people end up doing in college anyways, because you're too tired to listen to the lecture. So you end up going home, you pick up the book, and you learn it at your own pace.
Are there any certain books that helped you out that you'd recommend, or websites?
So I didn't use any books when I was going through. I did recently. My friend had a whole series of books for the CompTIA certification. And so I've got those, and I need to start going through those because I need to work on getting that certification. But I think that a lot of it is just, it depends on what works for you. I am not so much a reading type of person. I don't learn a lot when I like just read something, but if I watch a video and I can see it done, then I'm really good. Like when I took calculus from, just in general, my instructor, he had these podcast problems he would put out. He would put out problems that he would work through on video. And if I wasn't getting something, I could always go back and watch the video that he was doing. And okay, well, this is the process. These are the steps to do it. Now let's apply this to this problem, see where I have an issue with it. And then if I need more, then I'll either ask or I'll go look it up or something. But generally that would be enough. Whereas if I can see it happening in front of me and I can visualize it, then it was really helpful for me.
Awesome. Well, I'm going to let you go and give you some time. I know you have another interview coming up after this.
Fingers crossed.
Fingers crossed.
Fingers are crossed.
I'm going to give you some time to contemplate that, and I know you're going to do great.
Thanks, Evan.
Yeah, man. I'm going to put all the links for all the stuff that I mentioned in the description of the video, so you can check out and support. I also believe that for Rock Immortal, you guys have like a Patreon, right?
Yeah, we have a Patreon. We're not doing anything actively right now, but there is a Patreon if someone just really wants to help support. We're hoping once the COVID-19 vaccine comes out, we can start putting on shows again. That's really going to depend how many shows and how big of shows we can put on. It's going to depend largely on, well, how much money can we afford to throw, because bands aren't going to play for free and venues aren't going to let us rent out for free, especially not after COVID. They're like, look, we're broke. We need money.
Right. So if you guys want to see some Phantom Witch, or if you guys want to, donate to them, go donate, go check out Phantom Witch, go check out Section 5150, go listen to The Guillotine. Yeah, thanks for being on, Quentin.
Thanks for having me, Devon.